Electrical Systems, we're the integrator on the Reclaimed Water project, and I'm here to do training for instrumentation and control panel. We'll go over briefly right now what we've installed in the field, and then we'll go over in detail when we go out to the field. First thing I have here is WaterMaster, ABB WaterMaster flow meter. In the field we'll talk about just basic alarms and alarm codes and troubleshooting. So that's what will be involved there. If you guys want to go into more depth, in depth, we'll go through a few menu options. The next thing we're going to go over is the Hydro Ranger for level and flow. And it's a Siemens Miltronics Hydro Ranger 200 with XPS 15 transducer. Next thing on the list is the Rosemount 2088 pressure transmitter with HART communication. Next thing I have in here is the USG gauge for pressure indication. We'll go over calibration and filling the gauge. And I have floats to go over. We'll go over that, where they're at. Float operation is very simple. It's either on or off. So I'm not going to go into too much detail there. And finally, pressure switches for high pressure shutdown for the pumps. That is all. PC, UPS, uninterruptible power supply for the control panel. Control panel that controls the 5 pumps outside. We'll go over what's in here. 2 PLC racks. This is the processor unit right here. Controls all the functions of the PLC through ladder logic. This is the power supply for rack 1, power supply for rack 2. Got an on-off switch inside. This Ethernet module must have 2 different Ethernet networks on this, I'm guessing. Luke probably went over that with you guys anyway. DI cards, the red ones, AC input, isolated input cards, relay output cards. You can do AC or DC on these relay output cards. Analog input cards for analog signals, obviously, like your flow and your pressure. Analog output cards mainly used for VFD control. I don't know of any other analog output signals that we're using. All right. Power supplies. Solar power supplies, 24 volt DC, 120 input. What are these? These are 5 amp output redundant power supplies. And this is the redundancy module. So as long as you got green lights on all of these, you're good to go. Red lights. If one of these goes out, this redundancy module will pick up the other one and you'll have power all the way through. These are the CFCB modules, which Allen Bradley makes. All these right here are going to the discrete input cards. Inside, these are all the fuses for those modules. So the power comes in, goes through a fuse, out to the field, and then returns. Let's see. 15 is not used, so you just pull these out. It's a little easier with the needle nose, but here's the fuses right here. All 1/4 amp fuses. There's a little LED, a red LED that will come on for a blown fuse indicator. So if you have some kind of issue you lost the signal, the first thing I would do is come in and look at all of see if there's any red lights on. All the breakers, this is for all the branch circuits out in the field or power going out to the field. Main breaker coming in. Main breaker feeds the UPS and then the UPS feeds the panel. All right, let's see what else. These are the discrete output modules. These are discrete input modules. These are fuses also, fuse blocks underneath These feed the loop power for the analog loops out in the field. They're only used on the pressure transmitter. Stuff that isn't powered from 120 volts use loop power, and that's where these fuses are. Also have red lights for blown fuse indication. These are the modules for the analog output cards. They have a little dip switch on them. Shouldn't be really touched, but that'll turn the output on and off. Let's see. Here's where the UPS is plugged into, so you never want to unplug that. That's getting power to the UPS, and then the UPS is wired up to here. Can you hear me all right, by the way? Or yeah. Okay. Here's the UPS itself. Just the way it was oriented, the way the plugs go, unfortunately it's the buttons are on this side. But if we go over, if we look in the manual, there's a few lights. So here's a troubleshooting guide in the manual. But you'll see a charge level on the battery, which will be 5 lights, and if it's dropping, it's a bad sign. If it's dropping, it's probably on UPS power. If you're on UPS power, you'll get an audible a beep coming out of it, so you'll know. Battery replacement, there's a bezel right here. You can pull off, and the batteries are behind there. In this book, I have the replacement battery module, part number, 3 to 5 years. If this network is set up, you'll get a lot of indication on SCADA saying there's a problem with the batteries, so that'll be your indicator to replace. But you might want to have an extra set a couple of years down the road just because you know it's going to need to be replaced. Fiber optic patch panel. Not much going here. This just goes back to the SCADA, I'm guessing. Fiber is needed when you're running longer than, I think, like 800 feet. Ethernet won't support that anymore, so you need to use fiber optic at that point. So these are all Ethernet converters. They take a signal from all the Allen Bradley equipment and convert it to TCP/IP so it can be used everywhere, universally. Just something Allen Bradley likes to do so they can make more money, honestly. So these 3 are all communicating back to the switch. And there's switches in the MCC sections also. So I guess the only other thing is we got a red light here for UPS fail. So, any questions? No? Well, I must have done a good job in there. Okay. Mag flow meter transmitter. If we turn around and look over there, that is the mag meter that it's hooked up to. So, signal wires come around back over to here. Real simple. Set up an MGD. Alarm. This is a really smart unit. If you have any alarms, they will come up. And to access alarms, you can go to diagnostics, all alarms clear. But if you have an alarm, I supplied all the alarm codes in the manual here. If you're more curious about that, you can go in, hit this right button, go to advanced. You can go down to process alarm. And there's a diagnostic history here. So one of the past alarms we had was simulated fixed current output. Happened twice. the time it occurred last and the time it happened, or the amount of time that it had been on. Let's see what else we have. Same thing. Qmax volume display overrun. That must have been flowing when we had the display set up incorrectly. That was probably on initial startup. And that is all. Any questions on the mag meter, on the transmitter? I don't really want to get too in-depth into setup because there's really nothing to do on that. Oh, you can't? Oh, I'm sorry. So did you guys see the process alarm screen and then the history? Okay. So if you get an alarm though, you'll get an alarm bell. It'll be unmistakable. And then you can hit this button and go to the diagnostics and it'll tell you what it is and a code. So long story short, real smart unit, detects problems way far ahead, and will let you know when you have future problems.
Does it default to the NTG page it does not touch for a while?
Yes, it does. But if you ever want to get back to it, you have hotkeys down here that'll tell you back or select. Just hit back until you get back to the main screen. So, okay, next thing is the Hydro Ranger for level. It's reading the wet well level. The transducer is right there, shooting down. Set up in feet. I wrote the empty distance, so from the transducer face all the way to the bottom of the wet well is 24.58 feet. The range right here, 0 to 23 feet. Well, let's go over the basic setup on this guy. Oh, we'll go over the handheld operator too. You guys have a handheld controller? The instrument guys will. Okay, but either way, there's a few hotkeys that are interesting. If you hit the milliamp key, it'll tell you what your milliamp 4 to 20 output signal is. If you can hit the temperature key, it'll tell you what the temperature is on the transducer. This is echo confidence, and this indicator right here is showing that we have an echo, or we don't have any loss of echo. If this part goes away, if this symbol goes away, you have a loss of echo, and you have a problem. If you hold the same key, the echo key, for 4 seconds, it'll tell you this is short shot echo confidence on the left. We don't care about short shot because we're doing a long shot. Short shot is less than 5 feet to the transducer. Long shot is 5 to 60 feet. If this number on the right drops below 5, that's when you'll see a loss of echo. That's echo confidence right there. And then there's one more key that's interesting here. This key right here will show you the distance from transducer face to process. You can use that many ways. It's good for setting up. If you have an empty tank, you can shoot the distance and you can say, all right, this is where I want the bottom to be. I'll go over the setup with the instrument guys. All right. Here is the gauge pressure transmitter tree for header discharge pressure. Not a lot to talk about, but the pressure transmitter is a HART compatible transmitter. You're not going to be able to do any setup without the HART communicator. You can do a simple low and high range if you have a known pressure. There's 2 buttons on top when you flip the cover around. I highly recommend not touching that unless you have to. The gauge itself, if you have problems with the gauge, you can reset this gauge to 0 if it goes off of 0 for some reason. But you have to have the gauge flat. You can unscrew the cover. That cover right there unscrews, and then there's a little screw on the needle right here that you can turn counterclockwise to go down and clockwise to go up. And then if there is some kind of problem, the gauge needs to be repressurized and tested to verify that it's still linear. The gauges have a fill port on top. If the glycerin gets low, or it gets contaminated, you can drain it that way and refill it through the top. Any questions on the transmitter or gauge? Okay. So last thing we'll go over is switches, flow switch and pressure switch. So go over to the other side. For high pressure shutdown, and then there's a flow switch we'll go over to. The pressure switch right here, it has two different set points. Ah, shoot. Sure, thanks. All right, so on the cal sticker, I've got cal stickers on all the instruments out here. This one's set to 165 PSI, increasing, so when it gets to 165 pounds, it'll shut the pump down. So there's dual switches here, so if you wanted to in the future do a low set point, you could do that too. So these two wires are wired directly into the MCC, and they don't go to our panel. They go into a time delay relay in the MCC, so if we get a spike or any chatter, it's not going to shut the pump down instantaneously. They're on a 10-second delay, I believe. This dial under here is the dead band. So when the dead band is when the switch trips, dead band is how long it takes for it to go back to its original set point. So if it goes to 165, our dead band is 5 PSI. It won't reset until it gets below 160. Set point is done with this screw. It's real simple. All this does is raise and lower this. There's a micro switch under here, and then the diaphragm pushes out and hits the micro switch. So when you go counterclockwise, it will drop the switch, and then when you go clockwise, it'll raise the switch based on, and so that's how you set your pressure set points. E-stop will shut down the pump, obviously, but what else it does is it shuts down all 120 volts to the whole pump. So this breaks the control voltage circuit in the pump, so you're guaranteed if you push this in, you will have safe operation to do whatever you need to do in the field. Flow switch, as you can see right off of the check valve arm. So simple, the check valve will go up when we flow, and if for some reason we lose flow, like we have the discharge valve shut for some reason, this won't go up obviously, and then it'll shut down. Again, a time-based thing, I think 10 seconds. I got one more thing to go over in the panel based on this. So here's the vault, and there's a low level float and a high level float in here. I don't know what where they're actually at. Anyway, but they're floats, and that's where they're at. I want to go back into the control panel and we'll talk about where these are wired into, because it's something a little different because of the explosion proof area that it's in. So, okay.